In the earliest days of internal combustion engines, maintenance requirements were frequent and extensive compared to modern standards. Early engine designs featured rudimentary materials and manufacturing techniques, leading to rapid wear of engine components. Valves, in particular, were prone to carbon buildup, warping, and seat degradation due to the high temperatures and pressures of combustion, coupled with limited cooling and lubrication technologies. Early cooling systems typically relied on natural water circulation or basic thermosiphon systems, which were inefficient at dissipating heat. Lubrication systems were similarly constrained, as the available oils lacked the additives and heat resistance that would later be developed for high-performance applications and general mechanical longevity. Without such advanced additives, early oils were prone to breakdown and contamination, accelerating wear on engine components. As a result, valve train reconditioning, commonly referred to as a valve job, became an essential part of vehicle maintenance. Before the development of specialized machines, valve jobs were performed manually using hand tools. The earliest methods for reconditioning valves were simple and labor-intensive. Mechanics would hand-lap valves using basic tools like wooden handles with suction cups or clamps to rotate the valves against their seats. An abrasive paste, often made from silicon carbide, was applied to the surfaces to grind away imperfections. These rudimentary tools were affordable and accessible, but required significant skill to achieve consistent results. They also highlighted the limitations of the time, as achieving precise concentricity between the valve and seat was difficult. Additionally, while this method was effective for minor imperfections, it could not address significant wear or damage. For more substantial repairs, mechanics turned to hand grinding, using rudimentary handheld tools to reshape valve faces and seats. These processes were labor-intensive and required a high degree of skill to achieve acceptable results. The lack of precision in these manual methods often resulted in inconsistent performance and reduced engine efficiency. The inherent limitations of these manual processes, combined with the boom of the automotive industry and the affordability of automobiles to the general public, spurred the development of specialized machines in the early 20th century. As the automotive industry grew and engines became more complex, the demand for more efficient and precise tools increased. By the 1920s, companies began introducing the first valve grinding machines, which revolutionized the process. These early machines allowed mechanics to recondition valves and seats more efficiently and accurately, reducing engine downtime and improving vehicle performance. Cedar Rapids Engineering Company, founded by Charles C. Hahn in the early 1920s, revolutionized valve grinding technology with their groundbreaking Kwik-Way grinding machines. These machines introduced precision-engineered chucks and innovative grinding systems that made it possible for operators with minimal training to achieve remarkably accurate results with significantly less effort compared to traditional methods. At the heart of this machine was the Kwik-Way 6-ball chucking system, a breakthrough in mechanical engineering that would go on to define the company's legacy. The new chucking system was heralded as a masterpiece of modern mechanical engineering in promotional materials, and it quickly became recognized for its unparalleled accuracy. This system remains the most accurate chuck used for reconditioning valves to this day. Alongside the valve refacer, Kwik-Way introduced valve seat grinders that also earned a reputation for excellence, and both products are still seen as industry standards. Though they have evolved over time, the core designs of these machines, developed in 1920, remain largely unchanged in the models produced today. It is estimated that Kwik-Way valve refacers have reconditioned over 2.5 billion valves since their introduction. One standout feature was its incorporation of diamond dressers, which allowed operators to shape grinding wheels with precision, ensuring consistent performance and extending the lifespan of the grinding wheels. This emphasis on precision and durability set a new standard in valve grinding technology. Cedar Rapids Engineering didn't just sell machines, they sold an entire vision of the modern valve job. Their sales strategy was as innovative as their machines. A hallmark tactic involved a Kwik-Way salesman offering to perform a valve job on the shop owner's or head mechanic's personal vehicle for free. This demonstration served two purposes. It allowed the shop owner to experience the machine's capabilities firsthand, and it provided an opportunity to showcase the machine's efficiency and profitability within the familiar setting of their own shop. Additionally, any customers who happened to walk into the shop during the demonstration were also offered the service for free, further emphasizing the machine's potential to draw in business. With a price tag of $250, these machines were a significant investment. Salesmen wisely addressed the cost last, often proposing flexible payment plans with a compelling promise. The machine would pay for itself well before the final payment was due. This pitch was far from empty. The machines delivered on their promise of profitability, accessibility, intuitive use, and superior results. In 1932, Kwik-Way expanded its product line with the introduction of the first modern cylinder boring machine, designed specifically for reconditioning engine cylinders. This innovation solidified Kwik-Way's position as a leader in the industry. During World War II, Kwik-Way's engineering expertise played a vital role in the war effort. The company's piston grinders were used to grind glass radio crystals, a task requiring the high level of precision that only Kwik-Way machines could deliver. Additionally, Kwik-Way produced thousands of torque wrenches for military use, many of which are still in service today and occasionally appear on auction sites. In the 1960s and 1970s, Kwik-Way began expanding its reach by acquiring several companies. The first acquisition was Lemco Products, a respected manufacturer of surface grinding machines and presses. This was followed by the purchase of Ward Products, a Canadian company known for its line of cleaning equipment. The third acquisition, Linotronics, marked Kwik-Way's entry into the growing wheel service market. Despite largely selling these wheel service products under private label agreements to major companies like Snap-on and Ford Rotunda, Kwik-Way made a significant impact. In this period, the company introduced the first on-the-car brake lathe, which quickly became the top-selling machine of its kind. By the mid-1980s, the valve grinding machine market, specifically, was dominated by the rivalry between Kwik-Way and Sioux Tools. We'll get to them in a minute. At this point, the market demand was still such that machines were traded back to the manufacturer via a dealer fairly frequently, usually every 2 years with a standard price tag around $2,500. Following the general decline of the automotive engine machining sector in the late 80s and early 90s, both the market for the machines and customers' expectations evolved considerably. As a result, Kwik-Way was forced to pivot and diversify. Throughout the 1990s, Kwik-Way faced significant challenges, including a shrinking engine rebuilding market. In response, the company carefully evaluated and adjusted its product lines to better meet the needs of the changing automotive aftermarket. This strategic redefinition helped position Kwik-Way for future growth. In 2000, Kwik-Way re-entered the wheel service market with a new distribution strategy and a renewed marketing effort. This included the launch of the Lightning Lathe, which became the fastest operating brake lathe in the world. The company also partnered with Cycam, a leading manufacturer of tire changers and wheel balancers, becoming their exclusive U.S. distributor. This alliance enhanced Kwik-Way's presence in the wheel service industry. Since this time, however, brake lathe technology in general is viewed as being obsolete. With the emergence of more affordable, overseas-produced brake rotors, the market for the technology has all but collapsed. Fortunately for Kwik-Way, in the same year, they acquired Iron Tight Products, who was the industry-leading distributor of crack detection and repair equipment, diesel injector, sleeve repair tooling, and coolant system additives. A year later, Kwik-Way expanded further with the acquisition of Van Norman equipment, a move that introduced the iconic Van Norman flywheel grinders. Kwik-Way machines have earned a reputation for building a well-supported machine. The brand offers the broadest selection of grinding wheel grades and the most extensive sourcing options and compatibility. Additionally, their diamond dresser is widely praised as one of the best designed systems in the industry. Kwik-Way's roots go back to the 1920s, and their very brand was based on the invention of modern valve refacing technology. That said, some would say that Kwik-Way's 6-ball chuck design has some known issues. While it may initially offer near-perfect accuracy, the ramps tend to wear out faster than the hardened balls, which means it's tough to restore that original precision. Keeping grinding oil and grit out of the chuck through proper maintenance can help extend its life. When the chuck does perform at its best, however, it offers a distinct advantage. The chuck stem turns true regardless of the stem's condition, and the machine can still produce a round valve head even if slightly off-center. Over the years, Kwik-Way has made significant refinements to its chuck design, drawing on nearly a century of experience. When it runs true, the results speak for themselves. Plus, Kwik-Way machines remain competitively priced, offering some of the best value in the U.S. market. In 1914, the automatic valve seating machinery company reorganized to produce spark plugs and tire valves. However, just 4 months later, the company failed. Its Swedish-born shop foreman, Franz Oskar Albertson, and a young office assistant, Harold Jacobson, seized the opportunity to found Albertson and Company. Their goal was to establish the, quote, best machine and tool shop. They took over the manufacturing plant left behind by the failed company. When World War I erupted, Albertson secured a 4-month Canadian wartime contract to supply 6,000 piston rings and repair tools for munition plants. This contract provided a much-needed boost for the fledgling company. In 1916, Albertson designed a hand-cranked valve grinder, a manual tool for seating engine valves. Soon after, he developed a valve lathe. These innovations laid the foundation for Albertson and Company's reputation as a leader in tool making. By 1920, the company had grown significantly, moving into a larger 2-story plant. Historical records show that Albertson and Company was producing 11 different tools and generating over $500,000 in annual revenue, equivalent to nearly $8 million today. During the 1920s, the company revolutionized the tool industry by introducing some of the first handheld power tools. This spirit of innovation continued in 1958 when Albertson and Company designed and produced its first air-powered tools, which would become the company's primary focus for decades. These advancements eventually led to the company's acquisition by Snap-on Tools in 1994. Despite its success in the power and air tool industries, Albertson and Company, later known as Sioux Tools, is especially well remembered in the automotive machining field for its valve grinding machines. While many small and often forgotten companies produced valve grinding machines in the early 1920s, Albertson Sioux emerged as a primary competitor to the Cedar Rapids Engineering Kwik-Way. In 1922, they introduced the No. 650 model valve-facing machine. Although Sioux's machines were arguably less accurate and more challenging to operate compared to the Kwik-Way, they gained popularity due to their lower cost, minimal maintenance requirements, and widespread availability. This combination of affordability and practicality cemented Sioux Tools' reputation as a key player in the automotive machining industry during the entirety of the 20th century. It is worth noting that Sioux Tools remained focused exclusively on producing hand tools, power tools, and valve equipment, never expanding its footprint into the broader field of automotive engine machining. In contrast, Cedar Rapids Engineering, which eventually adopted Kwik-Way as its official name, pursued a more diversified approach. The company ventured into various aspects of the machine shop market. This strategic diversification proved advantageous in the long run. By the 1980s and 1990s, as the automotive machining industry began its gradual decline, Sioux Tools was acquired by a dominant hand tool company, reflecting its limited specialization. Kwik-Way, on the other hand, adopted a more adaptive strategy, selectively acquiring other companies and integrating their best remaining products into its portfolio. This approach allowed Kwik-Way to sustain its relevance and influence in the industry despite the broader market downturn. Over the decades, valve grinding machines continued to evolve, driven by advancements in materials, manufacturing techniques, and user demands. One key innovation was the development of precision chucks. Early machines relied on basic chuck designs, which often required frequent adjustments. Later designs, such as Tobinarp's collet-style chuck, offered greater accuracy and durability. However, each design had its limitations, such as wear in the ramps of 6-ball chucks, or the extra step of chamfering of valve stems for use in Sioux-style chucks, or the need for frequent collet changes. Materials also underwent significant improvements during this period. Early valves were made from low-grade steels that struggled to withstand high temperatures, while valve seats were often machined directly into cast-iron cylinder heads, offering minimal resistance to wear. By the mid-20th century, hardened valve seats and heat-resistant alloys like stainless steel became standard. For high-performance applications, titanium valves and other exotic materials were introduced, further extending durability and improving heat management. The development of new abrasive materials and grinding wheel designs also played a critical role in improving the quality and efficiency of valve grinding. Machines like the Tobinarp, which ground on the end of the wheel, achieved superior finishes compared to traditional side grinding methods. The introduction of centerless chuck designs by Ingenious Devices Limited, IDL, in the 1980s allowed valves to rotate on their own stems, eliminating the need for fixed chucks. While innovative, these designs were often complex and challenging to implement and maintain. For those working with modern 4-valve heads, the limitations of older valve grinding technologies become apparent. The pilots and drivers of older machines lack the precision required for the small 5mm and 6mm valve stems and the tight clearances these engines demand. In contrast, older 2-valve engines with larger valve stems, such as 5/16, 11/32, and 3/8" sizes, were more forgiving. The stiff pilots on these machines held the driver and stone more accurately. With the looser valve stem-to-guide clearances of older engines, Achieving seat-to-guide concentricity within half a thousandth was acceptable. However, with modern engines, such tolerances would result in the valve failing to seat properly all the way around, leading to performance issues. Today, valve grinding machines and valve jobs are less common in everyday automotive maintenance, but remain essential in certain contexts. High-performance engines, particularly those using titanium or other exotic materials, require precise valve work to maximize power and reliability. Restoring vintage engines often involves reconditioning original valves and seats to preserve authenticity. Beyond automotive use, valve grinding machines are employed in industrial engines, marine engines, and other heavy-duty applications. The history of valve grinding machines and valve jobs reflects the broader evolution of automotive technology. From labor-intensive manual processes to the precision machinery of today, these innovations have played a crucial role in improving engine performance and reliability. Over time, the practice of resurfacing valves and the use of these specialized machines became less and less ubiquitous. Once, demand was so significant that it fostered a diverse market. Manufacturers developed machines tailored to various needs, ranging from intermittent use models for service shops to precision equipment for engine building facilities and robust designs for continuous production. This diversity reflected the integral role these machines once played across the automotive and industrial sectors. However, as the industry evolved, the widespread familiarity and shared knowledge surrounding these machines diminished. What was once a common expertise across numerous disciplines is now preserved by only a handful of skilled operators employing these machines in specialized environments.